For me to go over it? I think so. Okay. Let's do it, okay? So this is the definition of a derivative. So should we write it out?
Yes.
The limit as, what's my variable? H approaches? Zero. Just generally, what's the the general form? F of x plus h minus f of x over h. Great. That is my general form of a derivative. It is. We learned this formula on the first day of school. Also in Unit 2. Okay, anyway. So e is e to the x, right? So let me get a new marker. Okay. So e to the x. So this would be e to the x plus h minus e to the x over h. How's that for me doing e?
Perfect. Why would you put it to the x?
Because this is e to the x. So f of x plus h is e to the x plus h, right? That's not so bad, yeah? That's not so bad? This is so bad. Okay. Now, is this at x? No. It's at e. So put in e for x.
Oh, because f of x equals e to the... Okay, that makes sense.
Uh-huh. So now put in e for x and choose the answer. Yeah, just look really carefully. Look really carefully between them.
But like, if I'm putting e for x, but I already subbed in e, like, is it going to be a double e?
Yeah, that's okay. Look at the answer choices. There are lots of double e's. That's the e to the e. See them? See them? They're all...
How you use your e. The two that look almost the exact same.
I'm going to go with e.
That's not a terrible strategy. I know.
No, that's what I do all the
So the answer is E. When there's 4 multiple choice, Riley, just saying when there's 4 multiple choice, not 5, that works less because normally it's 2 and 2.
Yeah.
You know what I mean?
Normally
Oops.
I can get
So it will be, the answer is
E.
E.
It's funny.
Isn't that great?
About e.
Yes. That's great. Okay, that's from a previous year. Cool. Okay. Using the definition of E. Oh, actually, let's go on this. This is fun. Okay. I'll just do it around.
Need to take on our computer.
No. So I want to figure out what the derivative of E is. Okay. So I'm going to do a bunch of slopes of tangent lines. You ready?
Yeah.
Okay. As right here, I don't know. It's not going to have to do with ln because ln has to do with 1 over x, which is weird, right? But in calc, ln is actually not related to e. Ln is related to 1 over x in calc class. So in pre-calc, ln and e to the x are best friends. In calc, ln and 1 over x are best friends. And e is like over there. Best friends with, we're about to find out. Okay, so what's the slope here, if you were to estimate it? What's the slope? 1. Looks like about 1, right? What's the y value? 1. Okay, that's interesting. The slope is 1, the y value is 1. Okay, interesting. Let's go 1 comma what?
2.5.
I'd say about 2.718. One about somewhere around e. Isn't it 1 comma e, right? You know? Okay, anyway. Well, let's say like 2.5-ish, okay? So the y value's about 2.5, okay? Do you agree with the y value being about 2.5?
Yep.
Let's draw a tangent line there.
That is true.
What do you think about the slope? The slope is about 2.5, 3, something like that. So again, the slope is the same as the y value, right? Okay, let's do over here. I don't know. Let's choose -1, okay? What would you say the y value is at -1? About? 0.71 right there? No, I disagree. What if you were to estimate that, what would you say? 0.3, I would not say 0.5. That's a little off. 0.5 is there, right?
Up 1.
Yeah, I said 0.5.
Oh, 0.25, 0.25, like a third, 0.3, okay.
3.5.
Okay. 3.35, okay, so somewhere around there. like around, let's say a third, okay?
0.359.
That's the y value. Let's find the slope. Okay, so let's draw a little tangent line. Okay, let's draw a tangent line. What would you say is the slope of that tangent line? Yeah, like wouldn't it be somewhere around like, 0.3, a third, 0.25, something like that?
If I'm being honest,
What were you gonna say?
like, I'm kind of confused
Yeah.
why we keep picking point.
Yeah, so I want to see the relationship between the slope and the y value.
Okay.
Because the slope of a function, okay, here's the idea. The slope of a function equals the y value of its derivative. Okay? So I'm trying to like deduce what the derivative of e to the x is. So I'm like, if I want to deduce what the derivative of e to the x is, I'm going to take a bunch of slopes and like see if that's the y value. So right here again, I get the y value is somewhere around, I don't know, a third, and the slope is around a third. Isn't that weird how the slope is the y value? But do you see it?
Yeah.
Okay. The slope is always, let's just do generalization. The slope is always, finish the sentence. Yes, that's true. Slope is always the y value. The slope is always positive, right? The y value is always positive. The slope increases, y value increases. So the slope is truly the y value, okay? Slope equals y value.
Of the derivative?
Of itself, really. Like, the slope at any point is the y value of itself, right? Here's what we're building up to. The derivative of e to the x is e to the x. It's itself.
Oh, okay.
I really like that.
I refuse.
Oh my god.
Do you like that?
Yeah.
I want to express.
She covered that. So do you like not really have to take it over?
Well, it's a lot of times like, what if it's e to the 2x? What if it's e to the x squared? Okay? But this is good. The derivative is actually not going to be that hard. Okay? Of e to the x.
Wait, I thought that was the derivative.
It is the derivative. But a lot of times you'll have to use the chain rule. You know?
I said chain rule earlier, and you said no, quotient rule.
That's a different question.
That was a completely different.
Okay, so oftentimes I say the derivative of e to the u, okay, is e to the u itself. See how it's itself? The derivative of e to the u is e to the u. But times the derivative of the inside, and the inside is always the exponent. The u equals exponent. The inside is u equals exponent, okay? So when I say like u in these problems, I'm talking about the inside is the exponent. When I say du, that means the derivative of the exponent. This will become clear when we do problems. It's not going to be too bad. Yes, Melina.
Okay.
Okay, let's do some problems.
Wait, what's the fill in the blank for this one? Oh, wait, I didn't even write that. Hold on.
Yeah, that's the fill in the blank. E is its own derivative. We figured that out because the slope was equal to the y value, like of itself. That's crazy. This is the only function in the entire world that's like that, by the way. It's very special. Okay. All right, so let's do a problem. So this is my u here, right? I'm going to put it in parentheses just to indicate that it's an inside, right? Do you have this one?
No.
Is it out of order?
Yeah.
Where is it?
It's like these we were. Oh no, we don't.
I don't know what it is yet.
It's 4.
Oh, examples 1. Can you flip to examples 1?
Oh.
Examples 1 is on the bottom. Okay. Yeah, we gotta do some examples. We're not ready to like learn more yet. Okay, so f prime of x is e to the u, legit itself, times du. That's the answer. I'll rewrite it so it's like f prime of x. I'll put the 3 in front, 3e to the 3x minus 2.
Okay, wait, so when you integrate?
It's going to be backward. It'd be a third.
Okay.
The integral of that would be a third, e to the 3x minus 2. Yeah.
Never mind, I
Okay, so this is e to the u du. Okay? You want to do this one? Can we already do a problem by ourselves?
probably.
Let's see. Let's see.
Get up.
Okay, for h you have to use a special rule. Watch out.
Oh, it's product rule.
Yes.
Huh?
Why did these pop up? Can you raise your hand if you got g prime right? Hey, look at you. So it's not too bad taking the derivative of e, right? Not too bad? Okay, let's do this one. Now I observe that there is an x in multiple places. If there's an x in multiple places, you must use like your thinking product quotient rule. See how this is product rule? So the product rule is u dv plus v du, in case you forgot it. Go ahead. That's exactly right. And then so crisscross in that. Yeah. You simplify that little coefficient. That's correct, but just simplify it. Actually,
I mean, like, I would be worried if it wasn't though.
yeah, that's right. Plus
But they don't taste like a bad.
the 6x is 6 e to the
Not
3x.
the,
All right, you ready to do it? 2 e to the. Wait,
Oh wait, yeah. No,
there's something weird. Okay, you ready to do it?
I like didn't see the e. I just.
Are we ready? U dv, so I'll just write it out, 2x times 3 e to the 3x plus v du, 2 e to the 3x. So this is correct, this is my answer, that's what the derivative is, that's h prime. I can simplify this. How should I rewrite this? Shout out.
6x.
Yeah, 6x. That's it, good. That's it. Cool. So you just took the derivative of e with the product rule as your third example. Crazy. You wait, what do you do? What do you do?
I don't know what I did wrong.
Okay, nothing's wrong. Copy afterwards. Yes, that's what you do. It was just a copy mistake. You didn't like actually. Okay, should we do examples 2? You ready? Okay, let's do examples 2.
Uh-oh.
Okay, go ahead.
See, when you start off the lesson, it sounds very easy, and then I get fooled that it's easy.
You weren't really fooled though. You really just made a mistake.
No.
Oh, yeah.
I'm
Oh, you're
really
waiting
good.
for the other shoe to drop, so to speak? Yeah. Well, not yet.
Like you start off, I'm like, oh, it's pretty easy. Like I kind of get it. And
It's actually never going to get that hard. What I think is hard is the problems where it's like the velocity is x e to the x, or like find the acceleration, or like the maximum, and you have to make tables and stuff, and like number lines. But just like if you're given like an e, Melina, and it's just like take the derivative, it never gets that hard. Okay? I mean, you can be the judge, but. So this is just, there's no special rule because there's just an x in one place, e to the u, du. E to the u, du.
Huh?
Mm-hmm. So what's the derivative of that exponent is what you multiply by. You could also write this as, if you want to rewrite it as e to the negative 1/2 x. That might help. Find your du. Yeah. How's that for f prime? We good? You do a little rewrite. F prime of x is negative 1/2 e to the negative x over 2. Go. Oh, alert! For the next one, I notice I have an x in multiple places. What rule am I going to use?
Quotient rule.
Quotient rule. Okay. Low d high minus high d low over low square. So go ahead, set up your quotient rule. Take your time.
So how many years have it been?
Hold on. Mm-hmm. Yep. Yeah, I'm 35. And then I started when I was 24.
Are you gonna try to stay for 20 minutes?
We'll see. You know, they'll have me. It's not entirely my decision,
Yeah.
but it is partly my decision. Yeah, probably. I mean, you never know.
I don't think, I mean, you're doing great. It'd be kind of hard to
Oh,
find someone,
thanks, Riley.
it'd be kind of hard to find someone to teach calculus, like, teach it.
Like, you
Yeah.
teach like
We're like
how many
French on every
classes?
maternity leave as well.
You
Just
teach
like,
like
Right?
4 classes. You know, so you're
yeah.
No, it's
Hey, you
really,
wanna
I'm
use
just
tomorrow?
confused.
We
Like,
jinxed
why
it.
did they-
Yeah. I'm not that worried about being fired.
I don't know. I can be
That's
that
good.
old.
At all. High e to the 3x. D high equals 3 e to the 3x. Low d high minus high d low. Okay, so yeah, you can do that. Okay, so if you put the coefficients in front, it looks like this. How's that with the coefficients in front? Okay, now I can simplify this. I'm just going to make this x to the 4th on the bottom. Is that okay?
Yep.
I have 1, 2, 3 terms. There is a common factor between all the terms.
Do you have
Is it like, are all the 3 terms are divisible by what? X. Yes. So I'm going to divide everything. I'm going to take out an x from everything.
Even the bottom.
Even the bottom.
do that, would I be punished?
Then what?
No, but there's like, this is again with multiple choice, getting your answer to match the answer they give you. You know what I mean? Yeah.
Wait, so say that was 6 and the bottom was 2. Would you take out 2 from the bottom as well or no?
If this was 6, yes, you would.
Where is it?
Yep.
Why do you do that for mine? Why would you not simplify?
If like, okay, so if you have like 6x minus 3 all over 3, you can simplify this. Be like 2x minus, well, 3x. 2x minus 1 over x, right? Yeah. When would you not do that? So sometimes if this is like a 4, you cannot simplify it because there's not a common factor between all 3 of these numbers. You know what I mean? And that's the case here. There's not a common factor between 3, 2, and 1. But if I take out an x from everything, this would be 3x e to the 3x minus 2 e to the 3x over x cubed. I could have shown factoring out an x if I had wanted to. I could have shown like x, you know, x, and then that's what cancels. Okay, so let's do h. H, I look at it, there's only an x in one spot. So that means no product, no quotient, okay? This is a chain rule problem. So this is like to the fourth is my big outside. And when you multiply by the derivative of the inside, it can be like a little tricky. Okay, go. Try it. Find H prime. What is H prime? What's H prime? What is H prime?
Two L's outside.
Okay, so if you want a little hint, a little hint up there. So that's my little hint. Want to try? Mm-hmm.
Wait, you can put it to the prime?
Well, this is just a power rule, like 4 to the third, right? Like we know how.
Oh.
So this outside is like a quartic. It's like a polynomial. So the first thing you do is think of this like a polynomial. And you keep the inside the same.
So you derive it?
And then you multiply by the derivative of the inside. Okay? Let me see over here. Cool. You want to put all the coefficients up front?
Would I keep the three together or no?
So you would you keep the 3 together?
So do I need the answer?
Yes. Because the 3 is not on the inside.
Do I move these children?
Yeah, exactly. Yeah. Oh, exactly always.
Um,
Okay, let's do it together. So h prime of x is 4, inside stays the same, e to the x squared minus 3 to the third times, the derivative of the inside is e to the x squared times 2x. That is my answer. I'm going to put all my coefficients up front, but that's my answer.
What would happen if we left it like that?
It'd be totally fine. You'd get full credit, but if it's multiple choice, you know, again, we want to like make sure we're matching the multiple choice. So that's why simplifying is a thing. So 8x e to the x squared times e to the x squared minus 3 to the third, like that. Those are pretty weird complex functions, right?
Yeah.
Yeah. You guys are handling them. This is good. This is good. All right, we ready to learn a slightly, you know, more advanced thing?
No.
So e to the x is this. E to the x is an exponential, right?
Yes.
What makes it an exponential? There's an x in the exponent, right? Yes? So let's turn, wait, what am I, turn to this guy. So you have to turn back, please. Turn back a bit. Turn back, turn back, e. Okay, the derivative of any old exponential, okay? So my base is not e here, okay? My base is a. I should have made it b. I like doing b's in base, but whatever. Riley, you want to just, you know? So this is the proof. You do not need to copy this down. Can you just look here as the proof is like not really a thing. But the e and the ln cancel, so I know what the derivative of e is, right? So if I rewrite that, let's just skip the proof, it doesn't matter. That proof is, yeah, we don't need to know the proof. Okay, this is the result.
Wait.
I'm just gonna write, hold on. I'm just gonna give you the results. Do you have this summary page?
No.
Yeah.
Yes.
Yes.
No.
So I like writing it in this order. I wrote it in the order I don't like. So it's a to the u du, just like before, right?
LNA.
Times ln of a.
Why would you?
I mean, I can show you the whole proof, but here's how I'll explain it, okay? Now, let's say I were to apply, so do you have this down, this copy, and then I'll explain?
Not yet.
Okay.
Not write down the other one.
Yeah, I would write it down, because this is going to be a good summary page where we put it all
Got
down.
it.
Yeah. Okay, so let's say I do the derivative of this using that formula, okay? Like my a is e, like the irrational number e. So if I have the derivative of this would be e to the u du times ln of my base, right? Yes? Times ln of my base? You getting me applying this formula?
Yes.
ln of e. What happens? Yes?
I'm confused on like why you're adding
Because the base isn't e. So this would be good for like deriving 2 to the x, which we're about to do. So if you're driving an exponential and the base isn't e, it's literally anything else, normally it'd be like an integer, then you have to add ln of that base at the end. So it's like one extra multiply step. So do you see if I did this e to the u, see how it would be times ln of e? What's ln of e? 1. So see how this would be times by 1? So it wouldn't have to be part of the formula? Melina? Yeah, I will try to explain why. Yes, no problemo. Let's try. Okay. So I'm going to rewrite a to the x in terms of base e, okay? So e to the ln cancel out. We did something like this in pre-calc, you know the problem where it was like that open response where you had to do the regression equation and then rewrite it with base e. I don't know, whatever. E and ln cancel, right? So this is equivalent to that. How's this for you? That they're equivalent, okay? So I'm gonna rewrite this, see how, so those are equivalent. See how this has x in the exponent? So what can I do with that? If I have ln of a to the x, how can I rewrite ln of a to the x? X ln of a? If I have ln of a to the x, I could do this guy out front using, yep. So this gets rewritten like that. How's that? This I can make, what's going on here? This, oh yeah, so I'm gonna legit derive this, okay? So the derivative of e to the u is e to the u, see e to the u, times the derivative of the inside. Let's just stick that as derivative of inside and leave that like that for a second. I'm not sure what the derivative of that is, but this is like e to the u du. So what is the derivative of x ln of a? X ln of a is just a number. Do we agree? It's not a variable. A is a constant, ln of a constant is a constant, it's a number. So this might as well say 2x. What would the derivative of 2x be? 2. So the derivative of x times ln of a is just ln of a. So when I take the derivative of the inside, so to recap, this is my inside, and this is my deriv of inside. That is like the crux of why we're taking ln of the base. And then I can recancel this back. See how like that just like I can put this back up and like I can recancel the e and the ln and make it a to the x again.
Like
Yeah.
okay, so when we do this problem, we're
Yes.
looking for the derivative of each, right? Like when you do this, we're looking for.
You're only looking for the derivative of the inside, and then you just tag on an ln of a. This is not a derivative thing, you just tag on ln.
Yeah, I'm confused like why this. Well, I
Why
know
it's not there? Because that would have an invisible ln of e tagged onto it,
Well,
which is 1.
I don't know why we need like ln here to find the difference.
Yes, because of this. Let's do a problem. Should we do a problem?
I guess.
Okay. Yeah, we'll do it later. Okay. You ready to do it? F prime of x is e to the u du ln of base. You ready to say that in a second? Let's say e to the u du ln of base. Okay, 3, 2, 1. E to the u du ln of base. So, can you do it? It's not e. Oh shoot, it's not e actually. It's 2 to the x. It's itself.
Wait, you said e to the x.
Yeah.
So it's
I didn't
base to
say.
the x.
Yeah, it's like itself.
Oh, because the derivative of e to the x is itself.
Correct.
So 2 to the x is itself.
Exactly. That's much better probability than I did. Times.
Good job. Just
Stop, you're gonna confuse me, I get it.
Yeah, times. What's the derivative of the inside?
1.
1. So we'll skip that. Okay. Well, I'll write it. Times
Just pretend to
ln of 2. The
I
end.
want to know.
That is it.
See, I'm still confused.
Yeah. It all has to do with the derivative of the inside. It all has, so you can rewrite 2 to the x. Okay. Let me try as e to the ln of 2 to the x. See how I can rewrite it like this?
Because ln and e cancel out.
Correct.
But is it still?
So this is just a rewrite, and then that would be e to the x ln of 2. I mean, not e. Yeah, e. Yeah. So when I take the derivative of this, I get itself e to the x ln of 2 times the derivative of my exponent. What's the derivative of my exponent? What's the derivative of x ln of 2? Ln of 2. Because ln of 2 is, I don't know, like 1.5, let's say. So the derivative of 1.5x is 1.5.
Because I thought.
So that's
like,
where that comes from. It's legit the derivative of the is the du. Yeah.
Like in the beginning, you said how like e. I thought you meant like specifically like e. Its slope is always the same as y. Are you saying that goes for everything? That every slope?
No, legit only e to the x.
So then why?
If it's 2 to the x, it does have itself, but you have to multiply it by something else as well. So it's not like just itself. It's not. Its slope is not equal to its y value. It's equal to its y value times a number. Okay, should we try this one? Should we try g prime? Okay. Can you try g prime? Go ahead. G prime of x. G prime of x. G prime of x. What is G prime of x divided by
Do you want to go off that?
no. That is.
So that's.
She said that
You may not multiply that in like that. Okay, so its derivative is itself 2 to the 3x times, you ready? Times
ln of 2.
3 times ln of 2.
So keep it like that?
Yeah, you can keep it like that. I guess I'll put the 3 at the beginning. So 3 times, because this would be like the y-intercept, remember? 2 to the 3x ln of 2. I would write it like that if it were me. But